Thank you for the opportunity to speak. So I'm just going to speak a bit about my journey in mathematics. So my journey started quite young. I was fortunate enough to have mathematics teachers in my family, so namely my grandfather. However, like most students, I was not willing to learn from him, even when he used to try and teach me when I was in primary school. So my family still brings that up to this day. But I think where it all changed was where I saw problem solving in mathematics. So in primary school, there was many challenging problems during class that I couldn't solve, and I was determined enough to try and solve them, and that sparked my curiosity and passion for mathematics. In fact, it was also some of the Olympiads that were shown on this YouTube channel that helped me develop my problem-solving abilities. Now, with this problem solving, it exposed me to more challenging problems and concepts, and hence I also realized that I need to understand things more deeply in order to solve the problems. Now, sometimes you might hear that mathematicians are lazy. It's in the sense that we want to find the easiest way to solve the problem. So I was also very competitive, so in fact, even in primary school, when we used to get, say, multiplication problems, I in fact discovered that multiplication and addition distribute over each other to solve those problems. In the sense that if you have three numbers, A, B, and C, and you first do A plus B and then multiply by C, you get A times C plus B times C. So that was something I discovered in order to solve problems quicker, and that also helped me spark my interest for mathematics. Moving on to university level mathematics, it was also a challenge for me because I think the notation and the symbols and the more challenging concepts did scare me at first or intimidate me. However, I found that once you sit down and actually understand these problems, it was not too challenging. And I think that with this love for understanding the actual concepts, it did help me, because I think one of the most memorable things I remember from my undergraduate studies is actually solving a question in an exam that in a third year analysis course in a way that was not shown to us before, and my lecturer after the exam did mention that to me. So I think solving the problem yourself is actually really memorable, and it will help you. So I think I'll leave it there. And just to touch on the fact that this understanding mathematics and difficult concepts also arises in different fields. For example, now I'm actually a postdoctoral researcher in physics, and I'm using this pure mathematics to study quantum mechanics. So it arises everywhere. And I'll stop there.
Glad to hear the science aspects there in the maths, because they tend to think it's separate. Well, all the previous ones were mathematicians, philosophers, poets, and scientists. So with that regard, so what role does science play in maths research today? Because it's funny, I'm a science education, and I'm a closeted mathematician. So I love maths, and I love the math and science. But it's a rare thing for me to see that bridge between two disciplines that shouldn't be. They're supposed to be Siamese twins. And that, to me, I still see it in our postgrad students as mathematics on its own. So how does your lead to that? Do you need that scientific background to understand the maths, or how does it complement each other? Because you're going into quantum physics, which is a little bit more detailed than just plain mechanics. So just your thoughts on that.
Okay. So I think science research actually motivates research in mathematics, because, as mentioned, mathematics arises everywhere. In studying those different fields of science, we try to understand the mathematics underlying those fields. and hence we studied those mathematical structures and objects in more detail, and this leads to new research in mathematics. And it also goes the other way around as well. Sometimes objects that were classically studied in mathematics arises in other fields of science. For example, there was work on prime numbers that laid the basis for cryptography in computer science. So science motivates research in mathematics, and sometimes the other way around.
And that's actually being shown at the school level.
At
No,
school
it's still
level.
solve for X factorize.
Yes.
They don't see the application for factorization in a field that is non-mathematics, although it's, I can't necessarily say this. So I think that is most probably what we should try to change, is to actually have an integrated part about mathematics, because I teach physics and I cannot teach maths without it. So I teach maths within physics.
Yeah.
Unfortunately, maths is still this maths, solve for X is an A and a B. So if you do simultaneous equations and you apply the maths, I don't know say simultaneous equations. So see, so that disconnect to me is what makes the next Nobel Prize winner. Yes, we do have a lot of mathematics research, but I still see a little bit of that disconnect, especially at school level.
Yeah, I completely
Because you get a
agree.
brilliant, I get my students get 90% in maths. I ask them the most basic thing in physics, that should complement each other. With 90 in maths, you must have 99 in physics, because that's application within. So that to me is just being a physical science teacher with a closeted mathematics. That to me has always been concerning with regards to our curriculum, and I don't know how, that's why I'm here.
Yeah,
I'm the spy here between the mathematicians. I want to learn from it. I want to see the research being done, and how can that be tapped into my field.
Could I chip in, though? Okay.
Yeah.
So I, as a side research, do so when I'm not doing technical mathematics, I am currently very interested in history of mathematics. Yeah, and I think learning where things come from can be very useful.
Yes.
So for instance, like I was thinking about this the other day. I was talking to my husband about how if you think about all different cultures, there's always a common thread. Every culture has art, every culture has music, every culture has dancing, and every culture has some sort of way to quantify something. And I think that's the easiest way to connect math to anything, and this is why I think math was born, is the need of us to make sense of something, count something, right? If I catch two, if I hunted 2 deers and you hunted 3 deers, means you're better than me, right? So it's this need of, there's always need of something from a society, and that gave birth to a new thing. So if we're going back to the days of Newton and them, they were actually doing physics, right? But now it became calculus, what they're doing. So was it physics, was it math? Well, it was kind of both. It was kind of both. So there's obviously now the universities, we human, we like to categorize things, right? We're like, oh, you're physics, you're math, or whatever. But actually, these are not boxes, separate boxes, right? There's always this connection. And I think that's also what is very important, I think, especially when we're teaching engineering students, for instance, or I taught biology students before and try to explain to them that you can see math in these kind of things as well. And it's an important thing, and I think it's just why I like the idea that Zura put out of the SAMS community to expand more people who are not professional mathematicians, like in having an engaged conversations with us and learn together, of these connections. And I look forward to having this. Yeah. Sorry. Yeah.
Just to follow up on that also, I love also the history of maths. Painter. None of them actually know him. So I like the history of maths as well. And with that, when you teach physics, and I just by chance heard I like talking to older people. The knowledge there is undeniable. And so one of them says it's a carpenter. And you know with a carpenter's tool, which they actually used a pole in order to do Pythagoras.
Yes.
It's just so amazing. That's the history of maths.
Yeah.
And it's still being used today, but it doesn't trickle down to the relevance of the subject.
Yeah.
So that's why I'm glad to hear what he's saying. going to the very heavy scientific field into and the complement of that. Because as you said, before science was science. It wasn't categorized. Just for a matter of ease, they needed to categorize it, but it's still science.
Yeah.
But today we treat it as an individual. And I think that is where we should actually have a...
Yeah.
Yeah, I think just to add on the conversation, the curriculum actually focuses on certain things. That's why you've got these compartments. That is why South African Mathematics Foundation has this kind of focus where when you look at the subject, you look at beyond the curriculum. But this happens in the form of competitions and Olympiads where learners are given problems that they have to solve without applying routine skills. That somebody tells you, do 1, 2, 3 things, the 5th thing is the conclusion. You don't have to solve problems following a routine thing. That's when you start realizing the beauty of the subject. Thank you.
Thank you very much, Kishan, for triggering a very deep and interesting discussion. If I could also maybe add, I also would like to add something to this discussion. Why stop at science?
Yeah, as an example, yes.
Because there is so much mathematics in the arts, in the languages. One of the big achievements of language theory of 20th century was to think of the structure of the language in terms of mathematical trees. If I'm not mistaken, it was Noam Chomsky who introduced this idea. And maybe that's why mathematics is separate. Because if you think of science as one entity, mathematics does not only fit there. Mathematics also fits in arts. It also fits in languages. You were talking about the quantitative side to mathematics. And that's a very important part of mathematics. But there is also another side, logic. Logic is the one that intimately links with language. And so maybe that's why mathematics is a unique spot. Because of its various links not only to science, but in a whole range of activities. When you wash dishes, when I wash dishes when my wife is not around, I do mathematics. There is a concept in mathematics called partition by equivalence relation. You want to classify the different types of dishes into equivalence classes. So that's my little input in that discussion.
The art is also nice because new technology was done in Grenada, Spain. So they found out that the artistic, all the known artists, what they've done, they analyzed mathematically. And it was actually accurate in terms of today's mathematical skills. So it's not just a Michelangelo there. They actually done the mathematics, so they were quite shocked to see how accurate the mathematical aspects are in the art they present.
Absolutely, and also if you look at like modern AI, which can recreate, it can basically compose music and even sing.
Yeah, based on
And AI is based completely on mathematics, and it can create something that artistically really feels sometimes, not always, appealing.
So it's a logic application. That's
Yeah,
what AI is.
yeah.
So I'm giving the data and how logically I make sense of it.
Yeah. Great.